Okay, good morning class. So today we'll be solving a numerical on lens maker formula. This numerical has been taken from your NCERT textbook exercise number 9.7. Before we go into your question, let us revise your lens maker formula. In your lens maker formula, you have a double convex lens. This double convex lens has two refracting surface A, B, C and your other refracting surface A, D, C. Your first refracting surface has a center of curvature C1. So it has your radius of curvature R1. Your second refracting surface A, D, C has the second center of curvature C2 and the radius of curvature R2. Next, refractive index mu is the refractive index of the given medium, where mu1 is the refractive index of the surrounding medium, mu2 is the refractive index of your glass surface. Is it clear? So now we know for a double convex lens which has a focal length f, I can write my lens maker formula as mu2 minus mu1 divided by mu1 into 1 by r1 minus 1 by r2. F is your focal length of the double convex lens, mu2 is the refractive index of the glass medium, mu1 is the refractive index of the surrounding medium, r1 is the radius of curvature, r2 is the radius of curvature for your second surface. If you have any confusion with your lens maker formula, it is advised you to go through the lens maker formula derivation again properly and then proceed with the numerical. Understand this equation thoroughly since we will be using this equation to solve our numerical. Okay, so in our question we have double convex lenses are to be manufactured from a refractive index 1.55 with both faces of same radius of curvature. What is the radius of curvature required if the focal length is to be 20 centimeter? Okay, so now let us understand the question. Double convex lenses are to be manufactured from a refractive index of 1.55 with both faces of same radius of curvature. Now what does this mean is that you have to make a double convex lens. You have to make a glass. The glass which can be used in your spectacles. Clear? Depending upon the kind of a problem, and the problem, let us suppose it can be cured by using a double convex lens. So you have to make a double convex lens. Now there are some points which we will go through before we deal with the question. Okay, now your double convex lens means, double means two, that means it has two refracting surface. This single lens has two refracting surface. Your first surface A, B, C and your second surface A, D, C. So this is your double convex lens. Now your first surface A, B, C, this has a center of curvature C1. If C1 is the center of curvature, then R1 is the radius of curvature for your first surface, which is A, B, C. Now your second surface A, D, C has a center of curvature C2. If C2 is the center of curvature, then the distance between the C2 and the optical pole is the radius of curvature R2. So R2 is the radius of curvature for your second surface ADC. Clear? Okay. Now let us look into the question and try to sort out the details given here. Double convex lenses are to be manufactured from a refractive index 1.55. Underline your refractive index 1.55. What does this mean? It means this surface. How much will be the refractive index? This double convex lens has to be made from a glass surface which has a refractive index 1.55. And we know from your formula that the refractive index of the glass surface, is how much? Mu2. This mu2 is the refractive index of the glass surface. So I can write mu2 equals to 1.55. Next, with the both faces of same radius of curvature. Both the faces, which are your faces? Your face or your surface ABC and your other surface ADC. Both of them has a radius of curvature R1 and R2 respectively. So we can write R1 radius of curvature for your first surface equals to R2 radius of curvature for your second surface equals to R. Let R be your any random value. Clear? So underline your same radius of curvature. Next, they have asked what is the radius of curvature required if the focal length is to be 20 centimeter. They have asked us the value of the radius of curvature. What will be the distance of this radius of curvature? What will be the distance of this radius of curvature so that my focal length will be at 20 centimeters. So underline 20 centimeter. So F equals to 20 centimeter, which all means if you have an object in front of your lens, you have to make the lens in such a manner, or you have to adjust the lens in such the manner that the radius of curvature, this radius of curvature, this two radius of curvature should be at what value? So that my focal length, this focal length should be how much? 20 centimeter. Clear? Now we know our lens maker formula is 1 by f, your focal length, equals to mu2 minus mu1 divided by mu1. Mu2 is the refractive index of your glass surface, which is 1.55. Mu1 is the refractive index of the surrounding medium. 1 by R1 is the radius of curvature for your first surface ABC. This is R1. And 1 by R2. R2 is your radius of curvature for your second surface ADC. This is your R2. Now in your formula, you have everything except for which quantity? Mu1. What is this mu1? Mu1 is the refractive index of the surrounding medium. Now I have already told you in your previous question, or what you can do is read the question again. You can pause the video here and read the question. If you have read the question, fine. Have they mentioned anything about mu1? No. So if such case appears where they have not given the value of mu1, what you can do is you can assume that the surrounding medium is made of air. If the surrounding medium is made of air, then what will be the refractive index of air? It is 1. Okay, fine. So now we will substitute these values in the given equation. So F is how much? 20. So I'll write 1 by 20. What is mu2? Mu2 is 1.55. So I'll write down 1.55. How much is mu1? It is 1. Minus 1 divided by mu1, which is 1, into 1 by R1 minus 1 by R2. Now be very, very careful. At this step, we have assumed R1 and R2 to be a particular value of how much? R. We have assumed only the value. Your value can be anything. It can be 10, 20. We have just considered the number. Now look here in the diagram. Your radius of curvature R1. In which direction it is measured? We know radius of curvature is measured from the optical center to the center of curvature, from left to right. Is it clear? And my incident light always goes from my left to right. Now, are they measured in the same direction? Yes. If they are measured in the same direction, what happens to R1? Will it be positive or negative? It will be positive R. Clear? Similarly, your R2, this R2, it is again measured from your optical center O. Clear? Optical center O to the center of curvature C2. Now, in which direction it is measured? From right to left. And my incident goes from left to right. Are they in the same direction? No. If they are not in the same direction, then my R2 will be negative. Clear? For R1, R will be positive. For R2, R will be negative. If students have confusion, instead of this statement, you can write my R1 will be how much? Positive R. My R2 will be negative R. Clear? So let us substitute this value. 1 by R1 is my positive R. 1 by R2 will be my minus R2. Now minus and minus, fine. This 2 will become plus. Is it clear? Now coming back to our original equation. 1.55 minus 1. Okay, students who have a problem with their mental maths ability can use the calculation, and the rest can follow up. So 1.55 minus 1 is how much? 0.55. 0.55 divided by 1 is how much? 0.55. And 1 by R1 will be positive of R minus R2 will be negative of R. Next, my 0.55 in fraction, I can write 55 by 100. So I have 1 by 20 equals to 55 by 100. In this case, minus and minus becomes positive. So I'll write 1 by R plus 1 by R. Clear? Now 1 by R plus 1 by R will give me 2 by R. So I have 1 by 20 equals to 55 by 100, 2 by R. Now, why we have taken 5500? Why not 0.55? It is because for your simple calculation. Is it clear? Now, what you can do next is this 2 multiplied by 55 is how much? 5 2s are 10, carry over 1, 5 2s are 10, 11. So I have 110 divided by 100 into 1 by R. Can I send this R to the other side and 20 to the other side? Your cross multiplication. So I have R equals to 110 divided by 100 into this 20 comes up here. So it will be 20. Now 0 and 0 gets cancelled. 0 and 0 gets cancelled. So I have in denominator only 1. So 11 by 1 will be only your 11. So 11 into 2 will give me how much? 22. So how much is my radius of curvature? It is 22 centimeter. What does this mean? For my convex or my double convex lens, for my convex or double convex lens, they have said that the focal length to be at what distance? 20 centimeter. And when is it possible your focal length will be at 20 centimeter? It is possible only when my radius of curvature is how much? 22 centimeter. That means this radius of curvature, this distance should be how much? 22 centimeter. So as this distance should be how much? 22 centimeter. If there is any confusion, you can ask me in the comment section. Is it clear? Okay then, thank you class.